Welcome back, everybody. In this video, we're going to dive into getting some basic routing capabilities up and running. And all I'm going to do is on ASA v1, I'm going to show you how to create a static route in the very beginning. So we're going to configure ASA v1 to point towards R1 on the gig0/0 interface. We're going to create a route out. And now what this is going to allow us to do is be able to reach the ASA via the ASDM. So we'll take a couple of minutes in the very beginning of this video to go through and configure the route, and then once we have that that defined, we'll be able to go through and access the ASDM. Also, I'll go through the initial steps in order to configure the ASA to allow ASDM connectivity and go from there. So let's go ahead and begin our configuration. And so I'm actually going to go to global config and type in no logging enabled, so that we're not going to get a bunch of pop-ups and whatnot. So from a routing perspective, if we look at R1 and we see show IP interface brief, we'll see that we have a connection to, bring this down just a little bit, gig 3. Okay, so gig 3 connects us to, so gig0/0 connects us to 10.1.10.1, or the 10.1.10 network. So now what we'll do is we'll focus on setting up that subnet on ASA v1. So that's where we're going to spend the majority of our time, at least the beginning here. So I'm going to go type in on interface gig0/0. So interface gig0/0. I'll type in IP address is going to be 10.1.10.10/24. And I'm going to use the name if command of name if is going to be outside. And I'm going to type in no shut. It's automatically going to get a security level of 100, so we don't have to worry about that. So show interface IP brief, and we have that up and running. So now we have the outside interface operational. The next thing we're going to do is we're going to exit out the interface commands, and we're going to go ahead and we're going to go and do the next step, which is create the default route outbound. So let me go ahead and type in, let me do the route first. So I'll type in route. And then you have a couple of options here. You can type in outside. In this particular case is what we're going to be doing. Route outside. And then what network we want to reach. So this is no different than a static route on a Cisco iOS router or Cisco iOS switch. Just the concept of pointing towards the interface first is a little bit foreign. It's a little backwards, but that's the way ASA does things. There's a lot of things that the ASA does globally, and this is one of them. ACLs are done globally. They're applied to the interface in a global format. We'll talk about that here in an upcoming video. But we're going to type in 0 and 0. Now, this is going to allow us to define a default route, and then we can specify the IP address of the default gateway. So 10.1.10.1. So we type in show run route. We're going to see that. And then you'll notice how 0 is not concatenated, but expanded to 0.0.0.0, 0.0.0.0, or a default route. So now we do a show route, we can see that we have a default route in the routing table. Now I should be able to ping 10.255.1.1. And I can. Now, what that basically allows us to do is 10.255.1.1 is a interface IP address on my home router, which connects us to the internet. Now what that also does is it allows me to go out and, from my desktop here, go out and reach the ASDM of this ASA. But we have to do a little bit of configuration before we get to there. So what we're going to do is we have to do the first thing, which is HTTP server enable. And then we have to specify what subnets we want to allow the HTTP server to allow in. So what source subnet? So HTTP question mark, and that's the first line up there. We're going to say 10.0.0.0 and a /8. So anything 10. And then we're going to specify in on which interface. In this case here, I'm going to say outside because we're coming in from the outside. You can apply it to whatever you'd like. Now, normally, if I'm going to be applying anything to an outside interface, I'm going to go find out what my local public IP is. So I'll do like an IP chicken, or I'll go to Google, what's my IP address, something along those lines. And that's going to allow me to get that specific IP address that I am coming from, create a host route, or basically a /32 host allowance for a permittance of the HTTP connection. So that's going to allow me to go do that. So I could type in HTTP, and I could type in, let's hypothetically speaking here, say, and we were coming from 14.2.65.98. Then I would do a /32 if I want to do a host route. So that would be potentially a valid public IP address that you might be coming from, and you would need to allow traffic from that IP address to be able to reach this ASA via the ASDM. That's what I mean when I see that. Now the next thing we have to do is we have to tell the HTTP service what credentials are you going to use to log in with. We're going to type in AAA authentication for HTTP is going to use the console. So basically just any type of connection into the device, and then we're going to specify the local database. So I type in, so now here it says local database is empty. Use username commands to define local user. So I would say in this case here, username is going to be Rob with a password of Cisco and a privilege level of 15. Okay, so now I'm good to go there. I've done all the steps that I need to in order to gain access to this device. Now, what I can do is I can type in ping 10.255.10.7, which is the IP address of the PC I'm recording on, and I should be able to reach that. If I can ping it and it can respond, that means that there's end-to-end connectivity. So what I can do now is the next step, which is pulling up the ASDM. Let's go ahead and do that. So I'm going to go ahead and pull this over. So 10.1.10.10, I'm going to come down here, type in Rob, and then Cisco, and then remember my username. And so by doing that, it pops up. It says, do you want to allow this connection? Basically, it sees the self-signed certificate of the ASA's, it sees the self-signed certificate from the ASA on the web server as self-signed. It doesn't trust it. So I'm going to say, it's okay. You can do that. So it's going to go ahead and it's going to load the software. Now, mind you, all of this software is already running on the ASA. You don't have to upload anything or do anything to it. I'm going to go ahead and I'm going to bring this guy over. For some reason, it likes to go on my other screen. But this is what you end up getting. This is the ASA that we're going to connect to. Now, as it sits right now, everything is up and running and operational. So this is the ASDM. So this is one of the things we're going to be using down the road. And so now that I've gotten this part up and running, we can do some other things. So I'm not going to do a deep dive introduction to the ASDM quite yet. I'm going to wait until I'm going to use the ASDM to do some of the configuration that I want to do. Some of it's going to be the command line and stuff like that. But I wanted to do at least this level of configuration to show you that it does work. So now that we have access to the ASDM, that means that everything's working the way that we need it to. Now, there are multiple ways to interact with it, and we're going to be covering that. I will do a video on breaking down how the ASDM works, a little bit of a guide to how things operate inside of it. And then we'll dive into some stuff later on down the road in an upcoming video. So I'm going to go ahead and click close. Right now, we're going to stay on the command line. Now, as it sits right now, what I want to go do is I want to take this to the next level, and I want to look at some dynamic routing just to prove that it does work. So what I'm going to go do now is I'm going to go ahead and configure dynamic routing. So I'm going to start off with Ospf because Ospf is already running on the routers north of ASA v1. So router 1 and VIOS. So to do that, I'm going to type in router Ospf, and you can only run 2 processes of Ospf. I'm going to type in process 1, and now that I'm underneath here, I have a handful of commands that I can do. So I can do multi-area Ospf, I can do some basic stuff. Like I can take a look at the capability, some compatibility. I can originate a default route. I can play around with the distance a little bit. I can do some route filtering. I can do a static neighbor adjacency with the neighbor command, or I should say a unicast neighbor adjacency. I can do a network command, so I can form a leveraging multicast. I can redistribute routes into Ospf. I can also do a summary address and play around with the timers, as well as do what they call nonstop forwarding. So all I'm going to do here is I'm going to type in network, and in this case here I have 10 networks. So we do a show interface IP brief. We're going to go and I'm going to say I want to enable Ospf, and I'm going to fix the redundant interfaces. I forgot to do that between videos. I'm going to go ahead and enable Ospf on this interface, so gig 0/0. So type in network, and I'm going to type in 10.1.10.0. Now, normally in iOS, you would type in a wildcard mask, so the inverse of a subnet mask. So 0.0.0.255. In ASA, it's 255.255.255.0. And then you still have to specify the area and the area ID. Now, what's going to end up happening is I'm going to form an Ospf adjacency here momentarily. And as you can see on router 1, there's an Ospf adjacency that's been formed. If I go back to ASA 1 and I do a show route, I should see some Ospf learned routes. Matter of fact, I see one right here, and I see one right here. So all the routes that I needed to learn have been learned. So everything that I would need to reach and be able to connect to, I have connectivity towards. Now, what I can do is I can go through now and if I wanted to, I could advertise the inside network. So all the stuff that sits south of ASAV1, the test routers, server 2, test 12, all that type of stuff can be advertised into Ospf and work that way. So these are some of the options we have. So what I will do is I will go ahead and do a show interface IP brief. I'll type in a network statement of 10.100.0.0, 255.255.0.0, so we're matching on the first two octets, and area 0. And then we'll type in network of 172.16.30.0/24, and then area 0. Now with all of that done, I can now take and go and advertise routes and stuff like that and get everything into the routing table as it needs to. Now, what that will actually entail or allow us to do here is now, once the server is able to reach out and actually talk to the internet, you will see this little no internet access issue. This will go away. So if I was to come up here and go command prompt and type in ipconfig, we have a statically defined IP address. So if I was to ping, 10.255.1.1, it may not work right away. It might take a couple seconds for things to synchronize, but eventually it will work. And when it does work, this server will then have internet access to it. Because as it sits right now, if we do a show route, we do have routes in the routing table. If I go to router 1 and I hit the up arrow again, or do a show IP route, you're going to see additional routes in here. You're going to see the 172.16.30 network, and you're going to see the default route from the rest of the network and stuff like that. Now, if I was to go in here and resynchronize the network adapter and stuff like that, you would see things change and internet access would be reachable. But for right now, I'm not too terribly concerned with that. I just wanted to get basic connectivity up and running and stuff like that from here. So that's basically how you do a basic static route and basic Ospf. There's more to it than that. And depending on which direction you go, if you go with we're starting out with Ospf. There is RIP available as well. If we were to do RIP, we could do that, type in router RIP and hit the enter key. And then there's the version, no auto summary. I really don't want to spend any time really on RIP. No one uses it in production. At least that one company I've seen use it, and it was, I'm not sure why, but they were. But it's there if you want to. We're starting with OSPF, and then we're gonna work our way down to EIGRP, and then we will deal with BGP and stuff like that. So we'll be taking a look at that. That's it for pretty much for this video. I want to keep it relatively short. Covered a few things, static routes, ASDM connectivity, and then basic OSPF. We're gonna keep this train rolling with the routing for just a little bit longer, and we'll take a look at doing some basic stuff with areas and stuff like that inside of the network. But again, if you really want to know the hardcore aspects of routing with OSPF, there's a lot of content out there that's already out there that have already done that, routing and switching wise. I don't see the value of putting a lot of time and effort into that here, but because this is more of a focus on the firewall capabilities of ASA, not so much its routing capabilities. But so now you know how to do a default route, you know how to enable ASDM access, and you also know how to add in OSPF if you ever need to. So I think that's a good first start, and we'll go from there. Until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next video.